Relay. My name is Jason Taylor, and thank you very much for joining us. What we're going to look at here in this video is taking a look at the wiring component of our smart relay. But we want to take a look, as we have in previous videos, about some of the other things, just to make sure that we lock it in. Okay, so the first thing that we want to do is take a look. There's a number of input devices that we have, and we have the main power requirement. So our input devices are going to be labeled with our I terminals. Okay, and our I terminals are inputs. Okay, our inputs 1, 2, 3, 4, 5, 6, 7, 8, indicated with an I. On these, we're going to have different things. And each controller is going to be a little bit different into what it has available. So on the particular controller that we're going to be using in our labs, the Eaton controller has what they call discrete. Let me spell that right. Discrete or digital. Okay, meaning that it is going to look at on or off. Okay, the digital power through or not. Okay, it's open or closed. And we're also can look at, a lot of the controllers are going to have analog. And they're going to be able to use analog. They're going to use the analog in a few different capacities. They're going to take a look at it in terms of either voltage variance, or they can also look at current. Now, this gets us really close into the realm of a PLC because the analog is something that gives us range. So with our discrete digital, we're going to either see a tank is full or not full. Okay, full or empty, it's going to give us those two choices. We might have intermediate ones, which are going to require more inputs, which we can locate at like half tank or whatever, kind of like an old RV indicator for your holding tanks. But the analog is going to allow you to see the full range. Okay, when we're talking about that, it's everything from the 0 mark all the way up to full. Okay, it's going to give you that full feedback, and it's only using one input instead of multiple. So there's a lot of really cool features for both of these. We're going to take a look at our discrete. Okay, for now, because the discrete is the easiest, and we're going to get into the analog a little bit more when we get into our PLC portion. So, and that's where these guys here would be used for our discrete. They're going to give us the variation of voltage back. We use a rheostat or whatever to vary the current as opposed to just current there or not there. Okay, so when we look at our overall inputs, and we're going to be looking at the discrete, so we need to pay attention to, and even our analog for that matter, we got to take a look at what we have available and our ratings for our IOs. Okay, inputs and outputs. The ratings are for the voltage, absolutely, as well as our current capacities. So our inputs, generally speaking, we don't need to worry about the currents too much because we're going to be using our own power supply, sending out to the field and back. So it's going to control that. But we do need to pay attention to them. Our outputs, however, we definitely need to take a look at because sometimes we end up exerting or overdriving them, and we can blow out our outputs. We also want to make sure that we're paying attention to our inputs as well, because we don't want to burn out those inputs if we're putting the wrong connections to them. So we're going to be very careful. So when we look at our input devices, we're always going to have power coming from our board. We need to remember the classic thing about our series circuits, okay, a return path out to the field and back. Every one of our sensors on our controller here is going to be just return paths. series connections, but we can also use, and we'll take a look at the different connection types here in a moment. So we're going to have to pull out our main power out to our field devices. Okay, that's our 24 volts supply from our controller. And then each and every one of these things coming back is going to have its own dedicated feed. So I'm now going to take a look at this guy here. Now I'm putting the 24 volts potential onto this terminal right there. And then I'm going to run this guy all the way back to my I1. My I1. So in the controller itself, the program that we set and we provide for it that we'll code in there is going to make that determination of what that means to it. Okay, all we're doing is we're providing a path for current or not current. Do we have power on the board or not on the board? If I want to use another control device out here, I just simply grab hold of this field power. Now we're making a parallel connection, and I'm going to provide it again to the terminal of my field device. And I'm going to run this guy back to here. This one would be now I2. I1 is a normally open device. It's not going to see current until I push that button. I2 is going to see a current path. So again, our program can determine how it wants to read that or how it's going to process that. And we can do that with any manner of devices here, whether they're open or closed. 24 volts once again, and now I can take a look at that return path here, and I can put that on any of my input terminals. But if you take a look at what's happened here, I have got one coming out to my field devices, and I've got from each individual device, I'm now coming back with one. So I can now create tremendous amount of control with this. In our smart relay, I can use timers. I can use just regular relay contacts like contacts. This is now using digital discretion inside instead of magnetic, but it's doing the same basic job. So I can get it to turn on a light if I push that button, or turn off a light if I push that button. I could do the same thing down here. So it's now giving me 3 different options to do whatever I want to within the program. And we'll take a look at that program in a moment. But that's not really the point of this video. It's really about the field wiring. Okay, now we get down to our outputs. So what I'm going to have here is this one is a control relay. And these guys are lights. Okay, my green light and my red light. So I can now set my program to initiate whatever I want in here by using our returns. Again, I've got my 24 volts. I'm going to pull out a common out to the field. And I'm just going to pull that. I'm just going to use the black one just to separate that. Every device is going to be slightly different as to their color coding, but this now is bringing down my 24 volts common. Okay, 24 volt common potential. And I'm going to make a connection to my green light here right now. Maybe I don't want to use a green to come down, but now from Q1, my output, I can just put that to this device, Q1. So when Q1 becomes engaged, it will now open a path for Q1. The Q1 is now the switch inside of our smart relay. It's going to turn on that light or off that light. It's going to control it through the controller. Same thing with my field wiring down here. I'm just going to extend this over to this spot here. I now have 24 volts on the back end here. I just need to make sure I can complete that loop by taking something from Q2. And I can bring my 24 volts down here to a control relay. Just remember that this has only got 24 volts potential. So if I want to run anything higher than that, I'm going to now take a look at how I can do that. Let's just say I've got a motor over here. And I want to roll that motor. Let's say it's a 240 volt motor. Now what I'm going to do is I'm going to take a look at my overall 240 volt panel. I'm going to run a black conductor to this, and I'm going to run my red conductor over here. Then I'm going to run my black conductor over here. So now I've got my 240 volts connected back to my source, but I'm now switching it through my control relay. So I now need to just find some way to energize that relay, and we're off to the races. Now what I'll do is I'll take try and use a unique color here, say Q3. Again, remember it's only 24 volts, so my control relay would ensure that it's 24 volt rated. So now when Q3 energizes, it's going to energize this magnetic relay, closing this set of contacts, energizing my motor at a higher voltage. It's giving me lots and lots and lots of potential here. Okay, lots and lots of potential. So we can control light loads, 24 volts or less. I could put in dropping resistors if I wanted to, or I can use my analog ones to give me a variety of different voltages, or I can use it to control other relays. Either way, I've got some control on this. We often will use little cube relays or whatever just to allow us to relay the low voltage signal coming from our controller to be able to control some higher voltages. So always be very careful about that. And the last thing that I want to do is just show you a real rough thing here on our overall programming. If we're using ladder logic to control this, I can now create and insert inputs. And I can also use that to put in my Q, my outputs. So now, if I was to set an instruction that looks like this, again, just using some logic, I can now say when 001 is closed, it will now pass current, turning on Q1, and Q1 is now going to light. I can also use that very same thing, and I can put this in here. This is where it's really cool because all of our changes, well, most of our changes can come from, let's go with 001 again. I can now use it for two functions. One single button is now going to be potentially to turn on two different things. So now Q1, if I push that button down, Q1 would become power back on the board. That's what that instruction is looking for. We'll go through that more. Meaning there'd be a current path, meaning that this one will become true, meaning that Q2 will also energize at the same time. I can play around with my programming in here. Program rules. Okay, and I mean that in the fact that it's really cool. It can change anything that we want based on the logic that we put into it. The whatever capacity we want to do. If I want to change the function out in the field, I don't necessarily have to change my wiring out in the field. I'm just going to change. If I also want to incorporate a timer in here, I can just put a timer bit in here and just say time on. time on delay. And I'm going to say 10 seconds. So when I push this button, it's going to take 10 seconds before I can engage that light. And again, it's not me putting in a physical thing. It's me just programming it in, changing it from a simple instruction of turning the light on to it now having a time on, and it can put in time off function too. So it can come on, I can put intervals, I can blink the light, I can do whatever I want based off of programming, not field wiring. Cool things. These control relays, these smart relays, are very close to what a PLC can do nowadays, especially with the analog functions. But they give us a lot of versatility and a lot of operability and a lot of capacity. I hope this helped. Thank you very much. Again, my name is Jason Taylor, and it's great to work with you on this.